Hello everyone, welcome to another exciting math problem involving number theory, a challenging topic for beginners. Here is the problem. Find all positive integer solution to the equation x squared plus y squared equals 3z squared. Before we uncover the solution, I encourage you to hit the pause button, grab your pen and paper and give it your best shot. When you're ready, feel free to share your answers in the comments. Then let's explore the solution together. Let's get started. If the equation were x squared plus y squared equals z squared, it would relate to Pythagorean triplets, indicating infinite many integer solutions. For example, 3 squared plus 4 squared equals 5 squared, 5 squared plus 12 squared equals 13 squared, 7 squared plus 24 squared equals 25 squared, 8 squared plus 15 squared equals 17 squared, and so on. In general, the solution x, y, z can be represented as m squared minus n squared, 2mn, m squared plus n squared for positive integers m and n. If we change z squared to 2z squared, a solution set x, y, z equals a exists for each positive integer a. Hence, there are infinite many integer solutions to x squared plus y squared equals 2z squared. Now, if we change z squared to 4z squared, we can rewrite 4z squared as square of 2z. Here, the solutions are linked to Pythagorean triplets, with examples like 6, 8, 5, 10, 24, 13, and 14, 48, 25. We leave finding the general solution as an exercise for you. In summary, there are infinite many solutions to the equation x squared plus y squared equals 4z squared. Now, let's focus on our problem for today. X squared plus y squared equals 3z squared. Suppose ABC is a solution where c is the minimum value. Therefore, a squared plus b squared equals 3c squared. Note that a squared is congruent to either 0 or 1 mod 3 for any positive integer a. From the relation a squared plus b squared equals 3c squared, we infer that a squared plus b squared is congruent to 0 mod 3. This implies that both a squared and b squared must be congruent to 0 mod 3. Consequently, both a and b are congruent to 0 mod 3. We can express a as 3m and b as 3n for some positive integer m and n. Substituting these values into the equation, we get 9m squared plus 9n squared equals 3c squared. Dividing both sides by 3, we get 3m squared plus 3n squared equals c squared. This implies that c squared is congruent to 0 mod 3, and hence c is also congruent to 0 mod 3. Please bear with me, we are nearing our final result. Let's write c as 3p for some positive integer p and substitute this value back into the equation. After simplifying, we get m squared plus n squared equals 3p squared. Here is the crucial step. What can we conclude from this equation? Yes, it implies that m and p is a solution to the original equation. And importantly, p is smaller than c. However, this leads to a contradiction, meaning our initial assumption is not correct. This concludes that there are no integer solutions to the equation x squared plus y squared equals 3z squared. This video demonstrates an important mathematical technique known as proof by contradiction, which is extremely useful in solving complex math problems. While we have successfully addressed this challenge, it's always beneficial to practice what you have learned. Using a similar method, I believe you can solve the following question. Feel free to try it and share your answer in the comments. That concludes today's lesson. I hope you enjoyed the video and stay tuned for more exciting math challenge in the future. Until next time, take care and bye bye.